please forgive my for sweet paper. It kind of got stepped on with something solid. I see the creases are rectangular. I have no recollection of stepping on it, but something happened to it, and I'm going to say it involved a foot and something with straight edges. We are solving real life situations with this ratio system that you've been working on. And what would be really difficult to figure out in your head, you now have a format to make sense of it, which I've said before. The important thing is, number one, always, always, always write your labels. With rates, you've got to have your labels. Now, you're going to do number 2 on your own, but I just kind of thought I would just give you a teeny little support and go ahead and write the labels for you. You can go from there. It's basically the scale from a map to real life. That's a common use for ratios or rates, proportionate rates. Number 3, this one's interesting, but I don't think I've encountered one like this before. 2 numbers, just any random number. So it's ratios, and ratios, they're going to be the same thing. You're not comparing different things. But I didn't have anything more specific than number. That's a peculiar one. 2 numbers are in a ratio of 3 to 2. Now this is really important. Put it in order. The smaller number is 36. Which one would be the smaller number? Obviously this one, because this one's bigger, so that one's going to be smaller. So I'll put 36 here. What's the larger number? I'll put in. This is pretty simple because 2 goes into 36. 2 times 18 is 30. 18 is 36. So 3 times 18 is n. N is 54. And you know what? If you were to reduce 54, 36, you know what you would get? Look at this, 54. Here's proof that they are proportionate. 54, 36, I can reduce them by 9. That becomes 6. That becomes 4. I can reduce these by 2. That becomes 3. That becomes 2. Right back where we started. That's how you know for a fact they're proportionate. Down to number 4. If a scale distance of 5 centimeters on a map represents a real actual distance of 175 kilometers, what actual distance does the scale distance of 3.5 centimeters represent? So you have a map and real, like a Mount Juliet map versus driving around in Mount Juliet. The map is 5 centimeters to a real distance of 175 kilometers. They use the metric system in this too. This would be, centimeters are kind of like inches. Kilometers are kind of like miles. Think of it that way. The metric system is a far better system. It's just not the one that we use in our country, and so I'm not as familiar with it. What actual distance does the scale distance of 35 centimeters represent? Since that is centimeters, not 35, 3.5. Since that's centimeters, I know that I'm putting 3.5 here with centimeters. So let's see. Actual distance. I'll put D for distance. I cannot reduce that. And this does not go evenly to that. So that means I cross multiply. 5 times D equals 3.5 times 17.5. Let me write that out. It's 35 to 67. 15, 2, 3, 4, 5. Oh yeah. Sorry, I was taught to just leave that blank, which is a terrible way to do it. And that's my habit now. And so I need to not leave it blank, I need to put that 0 there. 12, 10, 11, 6. Put my decimal right here. And I have 5D equals 612 and 5/10. To get the D by itself, I divide both sides by 5. Then D equals 612.5 divided by 5. Write it right here. 5 goes into 6 one time. 5 goes into 11 2 times. 5 goes into 12 2 times. 5 goes into 25 5 times. Find my decimal, bring it up. I have 122 and 5/10. 122 and 5/10. Make sure that's reasonable. If 5 centimeters is 175 kilometers, then 3.5, which is less than 5, will be, just less than 175. 122.5 is just less than 175, so that's reasonable. Do 5 by yourself, and I got you started on number 2.